Hello, in this lecture we will find out the value of angle ABC, the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees. We also know that side AD equals to side BC, and we want to find out the value of angle ADC, this angle. Okay, so we will start with the first method. First of all, we will define the length of side AC of triangle ABC as A, that is to say AC equals to A units in its length, and we will also define the length of side BC of triangle ABC as B, that is to say side BC of triangle ABC equals to B units in its length. We actually know that AD equals to BC. It is given us in the question that AD equals to BC, and we defined BC as B. According to our definition, BC equals to B units. So from this equation, we will derive that AD also equals to B. AD equals to B. AD equals to B. So first of all, I will present to you a new law, and we will implement the new law in our drawing. So actually the law is the law of sines. According to the law of sines, first of all, the law of sines is true in any triangle. So we can write down that in any triangle, so if we have triangle ABC, that could be any triangle. This is a triangle ABC. And we know that the length of side BC is equal to A units, and this angle is angle A. We also know that the length of side AC is equal to B units, and this is angle B, and the length of side AB is equal to C units, and this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B. And it also equals to C over sine C. And it is true in any triangle. Again, A over sine A equals to B over sine B equals to C over sine C. From this formula, we will derive that A over sine A equals to B over sine B. So we will implement the law of sines in our drawing. First of all, I will draw triangle ABC in a new page, and we will analyze triangle ABC. So this is triangle ABC that I copied from the original drawing. AC equals to A units, BC equals to B units, angle ACB is equal to 100 degrees, and the angle ABC equals to 30 degrees. We want to find out the value of this angle that we defined as angle X. We know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, this angle that is angle X plus this angle that is 100 degrees plus this angle that is 30 degrees. In total, the sum of those three angles must be equal to 180 degrees. Here we will subtract 130 degrees from this equation, and we will get that angle X equals to 130 degrees minus 180 degrees minus 130 degrees, it equals to 50 degrees. So we found out that angle X equals to 50 degrees. So we substitute X by angle of 50 degrees. Now we will implement the law of sines in this triangle, triangle ABC. According to the law of sines, we will get that A over sinus 30 degrees equals to B over sine 50 degrees. Here we will divide equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Okay, so in the next step I will copy triangle ADC, and we will analyze triangle ADC, and we actually will implement the law of sines in this triangle, triangle ADC. We have already found out that angle CAB equals to 50 degrees. So if we define angle BAD as theta, then angle DAC must be equal to 50 degrees minus theta, because of the fact that the sum of the angles, the sum of those two angles must be equal to 50 degrees. So angle DAC equals to 50 degrees minus theta. So if we define this angle as angle Y, then we know that the sum of the angles in triangle ADC must be equal to 180 degrees. That is to say, angle Y plus 100 degrees plus this angle that is actually 50 degrees minus theta. In total, the sum of those three angles must be equal to 180 degrees. So here we'll subtract 150 degrees from this equation, and we will get that y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. We will add to this equation theta, and we will find out that angle y equals to 30 degrees plus theta. So we will substitute angle y by 30 degrees plus theta. So actually the angle that we are looking for equals to 30 degrees plus theta, because we want to find out the value of angle ADC that is equal to 30 degrees plus theta. So I will copy this triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. Okay? So this is triangle ADC that I copied from the original drawing. This is point A. This is triangle ABC. We will implement the law of sines in this triangle ABC. We will get that A over sine 30 degrees plus theta equals to B over sine 100 degrees. Here we will divide equation number 2 by B, and then we will multiply it by sine 30 degrees plus theta, and we will get that according to equation number 2, A over B equals to sine 30 degrees plus theta over sine 100 degrees. So actually we have two equations. According to equation number 1, we know that A over B equals to sine 30 degrees over sine 50 degrees. This is actually equation number 1. A over B equals to sine 30 degrees over sine 50 degrees. And according to equation number 2, we found out that A over B equals to sine 30 degrees plus theta over sine 100 degrees. Okay, so we have two equations for A over B. So here we can create equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. Okay, so equation number 3 states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So equation number 3 will be A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2, that is to say it must be equal to sine 30 degrees plus theta over sine 100 degrees. Okay? So here we will cross multiply equation number 3, and we will get that sinus 30 degrees is 1 over 2. 1 over 2 times sine 100 degrees equals to sine 30 degrees plus theta times sine 50 degrees. Here we will use the trigonometric identity that states that sine 2a equals to 2 sine A cosine A, and according to this trigonometric identity we will get that 1 over 2 times sine 100 degrees. According to this trigonometric identity we will get that sine 100 degrees equals to 2 sine 50 degrees times cosine 50 degrees, and it equals to sine 30 degrees plus theta times sine 50 degrees. So here in equation number 3, in this side of equation number 3, 2 over 2 is 1, so 2 will get cancelled. We have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And according to equation number 3, cosine 50 degrees equals to sine 30 degrees plus theta in the next step we will use the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. Okay, cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees will be equal to sine 90 degrees minus alpha is 90 degrees minus 50 degrees. That is to say cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees, so cosine 50 degrees equals to sine 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees. So we'll do it now, and we will get that according to equation number 3, so cosine 50 degrees is sine 40 degrees. So sine 40 degrees equals to sine 30 degrees plus theta. So we found out that sine 40 degrees equals to sine 30 degrees plus theta. That is to say, 40 degrees equals to 30 degrees plus theta. Okay? According to equation number 3, we will get that 40 degrees equals to 30 degrees plus theta. We will subtract 30 degrees from this equation, equation number 3, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees, and the angle that we are looking for equals to 30 degrees plus theta. That is to say, angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. So angle ADC will be equal to 30 degrees plus 10 degrees. That is to say, angle ADC equals to 40 degrees. I'll repeat again. We actually found out that the angle that we are looking for, that is actually angle ADC, that equals to 30 degrees plus theta, will be equal to 30 degrees plus theta, that is 10 degrees, is 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle theta according to the second method. Here we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. So we find out the value of this angle, angle ADC, according to a second method. First of all, we will define side BC of triangle ABC as A. That is to say, BC equals to A unit in its length. BC equals to A. And we also know that it is given us in the question that AD equals to BC. AD equals to BC according to what is given us in the question from one side, but from the other side we defined BC as A. That is to say, BC equals to A according to our definition. From this equation, we will derive that AD also equals to A. AD equals to A. So we can write here that AD equals to A. In the next step, we will extend side BC of triangle ABC by a straight line. And from point A, we will draw perpendicular to the extended BC. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the intersection point from the perpendicular from point A and the extended BC as point E. We will define line segment AE as Y, and we will define line segment CE, this line segment, as X, and we will find out the value of this angle, that is actually angle ACE. We will define it as angle Y. We know that BC is a straight line because it is one side of triangle ABC, therefore it must be a straight line. We extended the straight line BC by a straight line. So CBE, we got line segment BE that still will be a straight line. Because of the fact that we extended the straight line by a straight line, we will get a straight line. So BE is a straight line. I will write it down that BE, line segment BE, is a straight line. This line segment. And we have the rule that the sum of the angles on one side of the straight line, or of a straight line, is equal to 180 degrees. Therefore, if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus angle Y must be equal to 180 degrees. I will write it down. 100 degrees plus angle Y must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So on the upper side of the straight line BE at point C, this point, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus angle Y must be equal to 180 degrees. Here we will subtract 100 degrees from this equation, and we will get that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle Y equals to 80 degrees. Here we can write down that angle Y equals to 80 degrees. In the next step, we will focus on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that tangents 80 degrees will be equal to AE over CE. I will repeat again. In the right triangle, triangle ACE, tangents 80 degrees will be equal to AE over CE. Okay? In the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. But we define the AE as Y. AE equals to Y according to our definition. And we defined line segment CE as X. So in conclusion, we actually found out that tangents 80 degrees equals to Y over X. Here we will multiply this equation number 1, by X, and we will get that according to equation number 1, Y equals to X tangents 80 degrees. Okay? Y equals to X times tangents 80 degrees. In the next step, we will focus on this triangle, the right triangle, triangle ADE. on the right, this right triangle, triangle ADE, we will define angle ADE, this angle, the angles that we are looking for, angle ADE, that is the angle that we are looking for, as angle theta. The angle that we are looking for is defined as angle theta. Here, if we focus on the right triangle, triangle ADE, we will get that sinus theta equals to AE over AD. Sinus theta equals to AE over AD. But AE equals to Y according to our definition. And AD also equals to Y according to what we have already found out, that AD equals to A. So we substitute AD by A. In conclusion, we found out that according to equation number 2, sinus theta equals to Y over A, and if we multiply equation number 2 by A and then we will divide it by sine theta, we will get that A equals to Y over sine theta. Okay, according to equation number 2, A equals to Y over sine theta. In the next step, we will substitute Y by X times 80 degrees because of the fact that Y equals to X times 80 degrees according to this equation, equation number 1. And we will get that according to equation number 2, A equals to Y, and Y is X times 80 degrees. Y over sinus theta. So actually, in conclusion, we found out that A, according to equation number 2, equals to X times 80 degrees over sinus theta, and according to equation number 1, we have already found out that Y equals to X times 80 degrees. In the next step, we will focus on the right triangle, triangle ABE. On the right triangle, the big right triangle, triangle ABE. So on the right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. I repeat again, on this right triangle, triangle ABE, we know that tangents 30 degrees equals to AE over BE. Triangle ABE, tangents 30 degrees equals to AE over AB. But AE equals to Y according to our definition. BE equals to A plus X. A plus X. So in conclusion, we actually found out that tangents 30 degrees, according to equation number 3, tangents 30 degrees equals to y over a plus x I repeat again, according to equation number 3, tangent 30 degrees equals to y over a plus x. Here we will substitute y by the value that we found for y in equation number 1, x times 80 degrees, and then we will substitute a by the value that we found for a in equation number 2. A equals to x times 80 degrees over sinus theta. So we'll do it now, and we'll get that according to equation number 3, tangent 30 degrees equals to y, and y according to equation number 1 is x times tangent 80 degrees over a plus x. A according to equation number 2 is x tangent 80 degrees over sinus theta, and we have also to add x. So here we will multiply x by sinus theta, and then we will divide it by sinus theta in order to have a common factor with this expression. X sinus theta over sinus theta equals to x, so we change nothing. Here we will move sinus theta from the denominator to the numerator here, and we will get that according to equation number 3, tangent 30 degrees equals to x tangent 80 degrees times sine theta over x tangent 80 degrees plus x sine theta. So here we have x in the numerator on this side of equation number 1, and we have also x in the denominator, so we can cancel x, and we also know that tangent 30 degrees equals to 1 over square root of 3 units, and it equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Here we'll cross multiply this equation number 3, and we will get that according to equation number 3 we will get tangent 80 degrees plus sinus theta equals to square root of 3 tangent 80 degrees times sinus theta. So here we will subtract sinus theta from this equation number 3, and we will get that tangent 80 degrees, according to equation number 3, tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. In the next step, we will take out a common factor of sinus theta from this side of equation number 3, and we will get that tangent 80 degrees equals to, so sinus theta was taken as a common factor, was taken out as a common factor. So inside the brackets, from this expression, what is left? What is left, it is actually square root of 3 times tangent 80 degrees. And what is left from minus sinus theta after we took from it sinus theta as a common factor? What is left? It is actually minus 1. So here we will divide this equation number 3, by square root of 3 times tangent theta minus 1, and we will get that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. So here we know that sinus, the tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees. So we will substitute tangent 80 degrees by sinus 80 degrees over cosinus 80 degrees, both in the numerator and in the denominator, and we will get that sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees, and we have square root of 3 tangent 80 degrees, again it is sinus 80 degrees over cosine 80 degrees. Here we will substitute minus 1 by cosine 80 degrees over cosine 80 degrees. Minus cosine 80 degrees over cosine 80 degrees equals to minus 1. So here we have cosine 80 degrees in the numerator and we have cosine 80 degrees in the denominator. So cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left? It is actually, in this side of the equation we have sinus theta. And sinus theta equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. So here we will multiply the denominator by 2 and then we will divide the denominator by 2. It is allowable to divide by 2 and multiply by 2 anything because you change nothing. So we'll do it now. And we will get that sinus theta according to equation number 3 equals to sine 80 degrees. I repeat again, we will multiply the denominator in this side of equation number 3 by 2 and then we will divide it by 2. So we'll get square root of 3 times sine 80 degrees over 2 minus cosine 80 degrees over 2. Here we divide it by 2 and here we multiply it by 2, so we change nothing. So we get that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 and square root of 3 over 2 is cosine 30 degrees. So we'll substitute square root of 3 over 2 by cosine 30 degrees. So we got here sine 30 degrees times cosine 30 degrees minus, and we will substitute 1 over 2 by sine 30 degrees. And actually we have here sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees. This expression is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. Okay, so according to this trigonometric identity, we can replace our expression by sine A minus B. So we'll do it now, and we will get that according to equation number 3, sine theta equals to sine 80 degrees over 2 times here sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees will be equal to sine A minus B according to this trigonometric identity, and A equals to 80 degrees and B equals to 30 degrees. So we will substitute our expression by sine 80 degrees minus 30 degrees. It is true according to this trigonometric identity. So actually we got that sinus theta equals to sinus 80 degrees over 2 sinus 30 degrees minus over 2 times sinus 80 degrees minus 30 degrees. 30 degrees minus 80 degrees is 50 degrees. So I write it down. We found out that sinus theta, according to equation number 3, equals to sinus 80 degrees over 2 times sinus 50 degrees. Here we will use the trigonometric identity that states that sine 2A equals to 2 sine A cosine A for the expression of sine 80 degrees. According to this trigonometric identity, we will get that sinus 80 degrees will be equal to 2 sinus 40 degrees times cosine 40 degrees over 2 sine 50 degrees 2 over 2 is 1, so 2 will get cancelled. And we will use the trigonometric identity that states that sine alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. So that is to say sine 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. So we can substitute sine 50 degrees in this equation, equation number 3, by cosine 40 degrees. So we will do it now, and we will get that according to equation number 3, sinus theta equals to sine 40 degrees times cosine 40 degrees. And I repeat again, we will substitute sine 50 degrees in equation number 3 by cosine 40 degrees, because cosine 40 degrees equals to sine 50 degrees. So here we have cosine 40 degrees in the numerator and cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled, and we left with the equation that sine theta equals to sine 40 degrees. That is to say, theta equals to 40 degrees. We found out that theta equals to 40 degrees. And theta, it is actually the angle that we are looking for. Here, theta equals to 40 degrees. So actually we found out that angle ADC, the angle that we are looking for, that is angle ADC, that also equals to theta, equals to 40 degrees. So in the second method, we also found out that the value of angle ADC that equals to theta equals to 40 degrees. In the next step, I will summarize the lecture. Actually, we wanted to find out the value of angle ADC, and we found the value of angle ADC in two different methods. In the first method, we defined side AC of triangle ABC as A. We defined side BC of triangle ABC as B. And it is given us in the question that AB equals to BC. For one side, it is given us in the question that AB equals to BC. From the other side, we defined BC as B. So from this equation, we will derive that AD also equals to B. So AD equals to B. Then I presented to you the law of sines. The law of sines is true in any triangle. So if we have triangle ABC, this triangle, that could be any triangle, and we know that the length of side AB is C units, the length of side AC is B units, and the length of side BC is A units. This is angle A, this is angle B, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. This is the formula. From this formula of the law of sines, we will get that A over sine A equals to B over sine B. And this equation is true in any triangle. And then I actually copied triangle ABC in a new page, and we implemented the law of sines of this triangle ABC. So this is triangle ABC. We know that angle ABC equals to 30 degrees, angle ACB equals to 100 degrees. This angle is missing, so we defined angle CAB, the missing angle, as angle X. And we know that the sum of the angles in any triangle, and especially in triangle ABC, must be equal to 180 degrees. That is to say, angle X plus 100 degrees plus 30 degrees must be equal to 180 degrees. We subtracted 130 degrees from this equation, and we got that X equals to 180 degrees minus 130 degrees is 50 degrees. So we found out that angle X equals to 50 degrees. Okay, so this angle equals to 50 degrees, angle BAC equals to 50 degrees. Then we implemented the law of sines in this triangle ABC. According to the law of sines, A over sinus 30 degrees will be equal to B over sinus 50 degrees. Again, A over sinus 30 degrees equals to B over sinus 50 degrees. We divided this equation number 1 by B, and then we multiplied it by sinus 30 degrees. And we got that A over B equals to sinus 30 degrees over sinus 50 degrees. Again, according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. Okay? Then I copied this triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. But first of all, we have already found out that this angle BAC equals to 50 degrees. Or this angle equals to 50 degrees. So if we define angle BAD as theta, then the rest, that is angle DAC, will be equal to 50 degrees minus theta, because of the fact that the sum of those two angles must be equal to 50 degrees. So if this angle is theta, this angle must be equal to 50 degrees minus theta. So we found out that angle DAC equals to 50 degrees minus theta. This angle equals to 90 degrees. It is given us in the question. And this angle is missing, so we defined it as angle Y. And we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So this angle that equals to 50 degrees minus theta plus 100 degrees plus angle Y, the missing angle, must be equal in total to 180 degrees. So we subtracted 150 degrees from this equation, and we got that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So Y minus theta equals to 30 degrees. We added theta to this equation, and we found out that angle Y equals to 30 degrees plus theta. This angle ADC, the angle that we are looking for, equals to 30 degrees plus theta. So I copied this triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. So this is actually triangle ADC. AD equals to B units, AC equals to A units. This angle DAC equals to 50 degrees minus theta. The angle that we are looking for, that is actually angle ADC equals to 30 degrees plus theta. And angle ACD is given us, it is equal to 100 degrees. And according to the law of sines, A over sine 30 degrees plus theta will be equal to B over sine 100 degrees. Okay, according to equation number 2, A over sine 30 degrees plus theta equals to B over sine 180 degrees. That is according to the law of sines. Here we divided this equation number 2 by B, and then we multiply it by sine 30 degrees plus theta, and we got that A over B equals to sine 30 degrees plus theta over sine 100 degrees. So actually we have two expressions or two equations for A over B. According to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. And according to equation number 2, A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. So actually we can create the equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. So this is equation number 3 that states that A over B according to equation number 1 equals to A over B according to equation number 2. So here equation number 3 states that A over B according to equation number 1, that is actually sinus 30 degrees over sinus 50 degrees, must be equal to A over B according to equation number 2, that is actually sinus 30 degrees plus theta over sinus 100 degrees. Here we know that sinus 30 degrees equals to 1 over 2. So we cross multiply this equation number 3, and we got that 1 over 2 times sinus 30 degrees equals to sinus 30 degrees plus theta times sinus 50 degrees. Here we use the trigonometric identity that sine 2 theta equals to 2 sine theta cosine theta in order to simplify sine 100 degrees. According to this trigonometric identity, the value of sine 100 degrees will be equal to 2 sine 50 degrees cosine 50 degrees. And here we have 1 over 2. 2 over 2 is 1, so 2 will get cancelled. And it equals to sine 30 degrees plus theta times sine 50 degrees. We have sine 50 degrees on both equations, on both sides of equation number 3. So sine 50 degrees will get cancelled. And we left only with the equation number 3 that states that cosine 30 degrees equals to sine 30 degrees plus theta. Then we actually used the trigonometric identity that states that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine 50 degrees equals to sine 90 degrees minus 50 degrees. Because alpha equals to 50 degrees. So cosine 50 degrees equals to 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. And so we have in equation number 3, we have cosine, according to equation number 3, cosine 50 degrees equals to sine 30 degrees plus theta. And we just right now found out that cosine 50 degrees equals to sine 40 degrees. So we can substitute cosine 50 degrees by sine 40 degrees in this equation number 3, and we will get that cosine 30 degrees equals to sine 30 degrees plus theta. So if sine 40 degrees equals to sine 30 degrees plus theta, it means that 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation number 3, and we found out that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we found out that angle theta equals to 10 degrees, and the value of the angle that we are looking for, it is 30 degrees plus theta. That is to say angle ADC equals to 30 degrees plus theta, and theta equals to 10 degrees. That is to say angle ADC equals to 30 degrees plus 10 degrees, and 30 degrees plus 10 degrees is 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees according to the first method. We finished with the first method. Then I presented to you how to find out the value of angle ADC according to the second method. In the second method, we actually defined BC as A, that is to say BC equals to A units in its length, and we have the equation that we know from the question that AD equals to BC. So if AD equals to BC, from one side, we know that AD equals to BC. From the other side, we define BC as A, so BC equals to A. From this equation, we will derive that AD equals also to A. AD equals to A, so we can write here that AD equals to A. Then we actually did a construction. We extended side BC by a straight line, and then from point A we drew perpendicular to the extended BC. So this angle is 90 degrees and this angle is also equal to 90 degrees. And we defined the intersection point between the perpendicular from point A and the extended BC as point E. And we defined AE as Y and CE as X. And we actually know BC is one side of triangle ABC, therefore it is absolutely a straight line. And then when we extended the straight line BC by a straight line, we will get a straight line. So BE will be still a straight line. Because of the fact that we extended the straight line by a straight line, we'll still get a straight line. So BE is a straight line, and we know that the sum of the angles on one side of a straight line must be equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. So 100 degrees plus this angle, that is angle Y, must be equal to 180 degrees. Here, 180 degrees plus angle Y, that is the sum of the angles at point C on the upper side of the straight line BE, must be equal to 180 degrees. Here we subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that angle Y equals to 80 degrees. Okay, angle Y equals to 80 degrees. Then we focused on the right triangle, triangle ACE. On this right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. Again, on the right triangle, triangle ACE, tangents 80 degrees equals to AE over CE. But we know that AE equals to Y and CE equals to X. So actually, we'll get that tangents 80 degrees equals to Y over X. Here, so tangents 80 degrees equals to Y over X. We multiplied this equation, equation number 1, by X, and we got that Y equals to X tangents 80 degrees. Then we focus on the right triangle, triangle ADE. On this right triangle, triangle ADE, we know that we defined the missing angle, the angle that we are looking for, angle ADE is angle theta. And in this triangle, triangle ADE, the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. Again, in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD, but AE equals to Y. AD equals to A. So in conclusion, we found out that sinus theta equals to Y over A. Here we multiplied the equation number 2 by A, and then we will divide it by sinus theta, and we got that A equals to Y over sinus theta. Okay, A equals to Y over sinus theta. And we substituted Y. We substituted Y by X tangents 80 degrees, and we got that A equals to Y, that is X tangents 80 degrees over sinus theta, and according to equation number 1, Y equals to X tangents 80 degrees. Then we focused on the right triangle, triangle ABE, on the big right triangle, triangle ABE. You can see that tangents 80 degrees equals to AE over BE. in the right triangle ABE, tangent 30 degrees equals to AE over BE. But AE equals to Y according to our definition, and BE equals to A plus X. So tangent 30 degrees equals to AE, that is 1, Y over A equals to AE, that is actually Y, over BE, that is A plus X. So in conclusion, we found out that tangent 30 degrees equals to Y over A plus X, and so here tangent 30 degrees equals to Y over A plus X. According to equation number 1, Y equals to X plus tangent 80 degrees, Y equals to X times tangent 80 degrees, and according to equation number 2, A equals to X tangent 80 degrees over sinus theta. So we substituted Y and A in this equation number 3, by Y and A that we found in equation number 1 and equation number 2. And we got that tangent 30 degrees equals to Y, and Y is X tangent 80 degrees according to equation number 1 over A plus X. And A equals to X tangent 80 degrees over sinus theta according to equation number 2. Plus X, we multiplied plus X, so we multiplied X by sinus theta, and then we divide it by sinus theta, so we change nothing. And here we have sinus theta in the denominator, so we moved sinus theta from the denominator to the numerator R here, and we got the tangent 30 degrees equals to X tangent theta times sinus theta over X times tangent 80 degrees over plus X times sinus theta. Here we have X in the numerator of this equation number 3, and we have X in the denominator, so X will get cancelled, and we left only with, first of all, we know that tangent 30 degrees equals to 1 over square root of 3, and we left here with tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. Okay? Then we multiply this equation number 3, and we got that tangent 80 degrees plus sinus theta equals to square root of 3 times tangent 30 degrees times sinus theta. Here we subtracted sinus theta from this equation number 3, and we got the tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. Here we took sinus theta as a common factor of this side of equation number 3, and we got the tangent 80 degrees equals to sinus theta was taken out as a common factor, and inside the brackets from this expression we will have square root of 3 times tangent 80 degrees. And what is left from minus sinus theta after we took from it sinus theta as a common factor? What is left from it is actually minus 1. So in conclusion, we got that tangent 80 degrees equals to sinus theta times square root of 3 times tangent 80 degrees minus 1. Here we divided this equation number 3 by square root of 3 times tangent 80 degrees minus 1. And we got that sinus theta equals to tangent 80 degrees over square root of 3 tangent 80 degrees minus 1. We know that tangent 80 degrees equals to sinus 80 degrees over cosine 80 degrees, so we substitute tangent 80 degrees by sinus 80 degrees and cosine over cosine 80 degrees, both in the numerator and in the denominator. So we substitute tangent 80 degrees by sinus 80 degrees over cosine 80 degrees in the numerator, and we did the same thing in the denominator. Instead of tangent 80 degrees, we wrote down sine 80 degrees over cosine 80 degrees, and minus 1 is minus cosine 80 degrees over cosine 80 degrees. Okay, so actually multiplied minus 1 by cosine 80 degrees, and then we divided it by cosine 80 degrees, so it will be still minus 1, so we change nothing. So here we have cosine 80 degrees in the numerator, we have here cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left here, that is sine 80 degrees equals to sine theta equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. Here we multiplied the denominator by 2 and then we divided the denominator by 2. It is allowable to divide anything that you want by 2 and then multiply it by 2 because you change nothing. So we did it and we got that sinus theta equals to sinus 80 degrees times 2 over 2. So it is times 2 over 2, so we change nothing. And we got that sinus theta equals to sinus 80 degrees times sinus 80 degrees. We substituted square root of 3 over 2 by cosine 80 degrees because of the fact that cosine 30 degrees equals to square root of 3 over 2 and minus cosine 80 degrees, and we substituted 1 over 2 by sine 30 degrees. Why? Because sine 30 degrees equals to 1 over 2. And here sine 80 degrees times cosine 30 degrees minus sine 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sine A cosine B minus sine B cosine A equals to sine A minus B. That is to say, we can substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we did it and we got that sine theta equals to sine 80 degrees over 2 times, as I've already mentioned, we substituted the expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. Okay, so we got the expression that sine theta equals to sine 80 degrees over 2 sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees. So we got that sine theta equals to sine 80 degrees over 2 sine 50 degrees. And we used the trigonometric identity that sine 2a equals to 2 sine a cosine a in order to substitute sinus 80 degrees by 2 sinus 40 degrees cosine 40 degrees. According to this trigonometric identity, it is true. So we got that sine theta equals to 2 sine 40 degrees cosine 40 degrees over sine 50 degrees. And according to the trigonometric identity that sine theta equals to cosine 90 degrees minus sine alpha equals to cosine 90 degrees minus alpha, we will get that sine 50 degrees will be equal to cosine 90 degrees minus 50 degrees. 90 degrees minus 50 degrees is 40 degrees, so we got that sine 50 degrees equals to cosine 40 degrees. So actually, according to this equation that sine 50 degrees equals to cosine 40 degrees, we can substitute sine 50 degrees in this equation, equation number 3, by cosine 40 degrees. So we did it, and we got that sine theta equals to sine 40 degrees over cosine 40 degrees, sine 40 degrees times cosine 40 degrees over cosine 40 degrees. Again, we substituted sine 40 degrees by cosine 40 degrees. So here we have cosine 40 degrees in the numerator and cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled, and we left only with sine theta that equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means the theta equals to 40 degrees. So the angle that we are looking for, that is actually angle theta, equals to 40 degrees, or angle ADC, that is actually equals to angle theta, equals to 40 degrees. Again, we found out in both methods that the angle that we are looking for, that is to say angle ADC that equals to angle theta, equals to 40 degrees. Okay? Thank you very much.